Okay, thanks for coming. That's the almost last talk on a Sunday, so thanks for sticking around and coming to listen to this. You have a cloud now, what? So, I used to start working on clouds, and really what I was looking at is how to get a clone of Amazon EC2. So I'm working on Apache Cloud Stack. I'm a committer on Cloud Stack and a member of the PMC. So we worry about low-level details of actually how you create Cloud Stack, how you manage storage, network, and so on. But really what I'm interested in personally is to get a clone of EC2, okay? Because we've learned everything from Amazon. And what we learned from Amazon, we have no clue how they're building their clouds, okay? They're probably using Zen, but we don't know much in terms of storage, in terms of network. We don't know how they're creating all their services. So it's kind of black magic. But what we know is that they have a bunch of services. So they have storage services. Of course, they have EC2 for compute. They have archive services. And now they're coming up with a bunch of analytics services. Of course, Elastic MapReduce that came out in 2009. Kinesis now for stream processing. Redshift for a data warehouse. So when you look at this in terms of cloud, I mean, it's nice that we're all talking about hypervisor choice and performance and SDN and storage solution, and Ceph works on this, but doesn't work with this version of libvirt and things like this. But when we look at Amazon, really, they are just spinning up new services left and right. Every month, every quarter, we have new services. And to me, that's what it's about. Okay, it's about building those services and then using them, whether it's for application deployment or application development in terms of virtual infrastructure, or actually having an application and putting it on there. So the landscape, we've seen it today and yesterday. The landscape in terms of open source infrastructure as a service solution, it's really Cloud Stack, OpenStack, OpenNebula, Yuka, Overt, Ganeti. We've heard a talk by the guys from Cinefo. I don't think there was any talk by Eucalyptus, but Eucalyptus was really the first software that came out that was trying to emulate Amazon and create a clone of Amazon. So that's fine, but really, what we want to do is actually, once we've built those, we actually want to use the API that they're exposing, and we want to serve services and use those services, okay? So that's really what interests me. So I'm not going to talk about these really, in details, but what I have is that I have some friends in Switzerland. They have this cloud exascale, and I play a lot with it because it's in production. It uses Cloud Stack behind it, and it's a fairly basic cloud in the sense that you just instantiate and create virtual machines. And it gives you virtual machines kind of like Amazon, which means that it's a public IP, and then you manage security group and key pairs. So a lot of things. I'm actually going to show you some demos, and we're going to use that cloud because it's in production. And my point being that even though we are building or we are trying to figure out how to build those clouds for within companies, private clouds, and so on, there are some of those that are not EC2 that are already in production out there. So Cloud Stack, originally it was just Cloud Stack, and then I just modified it Cloud Stacks because it wouldn't be fair to just do the Cloud Stack. But you'll see what I mean by this is that if we look at all the components of those YAS, of course they have something to handle compute, so virtualization, farm of hypervisors. They have something to handle storage, whether it's image catalog or data volume, and then networking. We've heard about SDN and things like this. So those are the three main components there. Then you have image management. So in Cloud Stack, we actually don't give it a name. It's just image management. In OpenStack, that would be Glance. Identity management, same in Cloud Stack. We don't give it a name, but in OpenStack, that would be Keystone. So compute would be Nova Controller, but for us, Cloud Stack, we don't have a name. But you see that in all those projects, whether you take OpenNebula, OpenStack, Cloud Stack, you're going to find those same things. And those three, they expose an API on top over there. They have a native API. I'm going to talk more about it. or they also have an EC2, an Amazon bridge. And that's really what we're going to use to build those additional services, dashboard and so on. So in terms of dashboard, for example, it's just an example to show you that all those components, basically all those systems have the same type of components underneath. That's the dashboard for CloudStack in Chinese, because I worked a lot on the localization. If you look at OpenStack, there is another dashboard called Horizon. And of course, if you look at OpenNebula, they also have a dashboard that's called Sunstone, I think, yeah, that comes with it. So you're going to find the same things in all those ES solutions. In terms of API, that's really the key, and to me, that's what the cloud is about. It's much more than virtualization. It's really exposing all the capabilities of those systems through an easy-to-use API. So CloudStack has a very extensive API. Every functionality is exposed to that API. It's not a pure REST API. I mean, it's HTTP JSON, but there's more than this to REST than just HTTP JSON. So it's more of a query API. OpenStack is, as far as I know, really fully REST API in the sense that you have very well-defined URI, and then you can use different types of methods, get, post, put, delete, to actually manage those resources. In CloudStack, everything is going to be a get or post. Okay. So they have APIs. So that's fine. So you've built that cloud. They expose an API. You're happy. You can start playing with this. Okay. So now, how do you do this? Well, so you go to GitHub and you look for clients. So you need a client to talk to that API, to that cloud. Left side is OpenStack. You do OpenStack clients. You get 72 repositories in GitHub. And then CloudStack, you do CloudStack client, you get 22. And then whether you're a Python guy, a Ruby guy, Java, JavaScript, you pick the one you want, okay? Okay. Only at FOSDEM do you see guys coming in and then passing in front of the... So, Python, lots of Python in OpenStack. Of course, it's all written in Python, but we also have Python clients in CloudStack. So really what's interesting there is that whatever language you're using, whatever app you're trying to do, you're going to find a client for that cloud on GitHub. The state of that client, we can debate, but there is something happening there. So let's look at a few clients. The next one is specific to CloudStack, but then I'm going to talk about a few ones within the Apache Software Foundations that are actually common to all of the IaaS solution, but also other cloud providers that don't provide software, but that provide cloud services. CloudMonkey is specific to CloudStack. That's really our CLI. So EC2 has an EC2 CLI, of course, that you install on your machine, and that's how you manage EC2. So CloudMonkey, that's for us. That's for CloudStack. You run CloudMonkey, and then you have access to all the APIs of CloudStack, and that's how you do very low-level operations in your cloud. And I'll show you some demos. It's as easy as pip install CloudMonkey if you wanna get it. Now, of course, I work in the Apache Software Foundation, so I like all the projects that I'm seeing at the ASF. There are tons of them, 150 projects at the ASF. libcloud is very interesting, and I work on libcloud because it's in Python, and I do Python. So even though I work on CloudStack, which is Java, I code more in libcloud. What you see with libcloud is it's actually a wrapper. It's a Python wrapper on top of all the APIs. Not only CloudStack, OpenStack, but also you see SoftLayer, GoGrid, DreamHost, Amazon, Google Compute Engine, and so on. So that means that if you're using multiple clouds, you take libcloud, and then you can write an application, and basically the differences in APIs are going to be totally abstracted, and you're going to be able to use that module. So now you're starting to see that, okay, those clouds are exposing APIs. Now we have wrappers. And of course, some of you are thinking standards, but we'll talk about that. So typical libcloud script looks like this. This is Python. You import the modules, and then you get a driver for that cloud. So here you see exascale. I just instantiate the exascale driver. I specify my keys. And then I have access to a list of commands that are common, that are the base API of libcloud. So list images, list sizes. Those are very basic functionality of every cloud. You know, list the zones, list the templates, list the instance types, starter node, things like this. And at the bottom, you see here, there's a deploy node method where you can actually start an instance and then pass scripts and execute those scripts on the deployment. So typical libcloud setup. And this is, even though I did exascale, which is my cloud stack cloud, if you remove that driver line, okay, all the rest is going to be valid for any cloud. OpenStack, OpenNebula, EC2. There is nothing specific about cloud stack. Well, almost. JClouds is another one that, who uses JClouds? Yeah, okay, one person, okay. Great. No, it's heavily used. JClouds is heavily used. It's another project at the ASF. It's a top-level project, right? Yeah, they graduated. So it's a top-level project. It was donated recently to the ASF. It's all Java. And basically, it's just like libcloud, but it's in Java. So it gives you a Java library that can talk to any of those clouds and abstract the differences in APIs. Okay? And it's used in lots of tools that you may use and without knowing really that there is JClouds. For example, if you guys have heard of Cloudify from Gigaspaces, it's using JClouds. Delta Cloud is another one that's Ruby. It's in Ruby, and it's also at the ASF. So here you see that the cloud doesn't matter because you have wrappers, and then the language doesn't even matter because you're going to find the client. And here, just at the ASF, you have 3 projects that do the same thing and that are in the language of your choice. So Delta Cloud is in Ruby. It's a little bit unfortunate. It was kind of sponsored by Red Hat or started by Red Hat, and then they dropped it a little bit, it seems. But it's the same thing. It gives you a wrapper on top of all the differences. So now that's great, but you have all those interfaces and nothing is standard. So there is no standardization on the API, and then there is no, all those wrappers are different. So we are seeing some standardization effort here. From DMTF, we have the CME standard that's coming up, which is an attempt at standardizing all those APIs for the clouds. And OCCI is another one from Open Grid Forum, OGF. But right away, you see the problem. Okay, we're talking standard, and I'm already giving you 2. So that's kind of problematic. I mean, to me, really, the standard is Amazon. That's the de facto standard. And it's not. They're not pushing it. They're not pushing for it to be standardized. But since it's so heavily used, that's really the de facto standard. It's going to be interesting to see what's going to happen with the Google Compute Engine that just was made GA, which is yet again a different API, and we'll see if that gains some steam and becomes more of a standard. Now, OpenNebula, for example, is pushing really hard to have EC2 compatibility. Of course, Eucalyptus was from the start an EC2 clone, so everything they do is EC2 compliant with Amazon. And actually, if you go to GitHub and you look for a Eucalyptus client, you'll find one, okay, which is Yuka. But in CloudStack, what we're doing, I mean, we recognize that EC2 is very important, so we have an EC2 bridge, and we're developing a new one to get better. And then we also have a Google Compute Engine bridge, which means that you can use the Google Compute Engine clients to talk to CloudStack. Okay, so we got that cloud, whatever solution you're using, exposes an API, and then you choose your wrapper. Okay, that's fine. But now we need to do things on top of this. So of course, one of my managers said, you're going upstack. I don't really like it, but anyway, that's what's happening. So on top of the clients, you're building up those services, okay? Then that's really what we're trying to do. So we're going towards platform as a service. And I took a clue again from Amazon Web Service because I knew about their CloudFormation service. And then I also knew about OpsWorks, but I didn't really understand the difference. So if you go to their page, they have an application management page. They have a nice FAQ. And there is this picture where basically it starts from the low-level services, EC2, start an instance, create a firewall, create a key pair, things like this, stop the instance. Very basic image management. Lots of control. And then you go towards building templates, so orchestrating multiple instances now. So you're defining the software running in those machines. You're defining the number of machines running, how they interact. And then you go even further until you reach Beanstalk, which is really now for your app developer who is going to take that app and just stick it through an API, and Amazon is going to do the magic. So somehow we have to find a way to go from IaaS, API, clients, and then move all the way so that we can offer those very nice PaaS services. So we have tools that go in that direction. Something like Apache Ware. It's a little bit dated right now, but it's in Apache, of course. It's based on JClouds, and what happens there is that you write a definition of the VMs that you want started, the software you want on them. It can use basic bash script for configuration, or it can use a configuration management tool. And then you start that cluster of instances, and it's going to be provisioned. That means that, let's say you want to build a MongoDB cluster or an Elasticsearch cluster. You define this in your file, in your JCloud template, feed it to Ware, and it's going to start. So that's great. But what we're seeing also now is from the guys in configuration management, I think we're seeing very, very interesting things, and the configuration management room was full yesterday. So that's just an example with Chef, but again, you can do similar things with Puppet and SaltStack and Ansible probably. So I'm here over there. I'm developing on my laptop. I have a Chef client, and I define my recipes for the software that I want installed in those virtual machines. And now what's going to happen is that from my laptop, I can actually use the knife tool from Opscode to actually directly deploy my node in the cloud, and it's going to install the software that I define. So I'll show you an example of this. But I think that's very, very powerful, because now you're bridging the gap between configuration management and actually using the cloud. So you're on your laptop, you have all those recipes, you push, and suddenly you have 10 instances with whatever you want, Elasticsearch, Hadoop, whatever. And the cloud almost becomes transparent. The next one, this is great, but lately I've been playing with Vagrant. Vagrantup.com, and Vagrant is a tool to basically create virtual machines, and initially to create virtual machines on your laptop so that you can use configuration management, whatever you decide, SaltStack again, Chef, Puppet, simple bash scripts, and you can define the software you want in those machines in a Vagrant file, and then it's going to create that instance. Now what's interesting is that Vagrant is coming up with plugins for all those clouds. So now you're developing, and at the same time, directly from Vagrant, you can push those instances in the cloud and build those infrastructure. You guys want to take a break and see a demo? I feel like I'm losing you, so let's do a demo. Okay. What do you want to see? Okay, I'm cheating because I know what you. So let's do Cloud Monkey, for example. So first, let me show you Exascale. Okay. So I have my cloud. That's Exascale. It's very big. If I get network, it's CloudStack behind it. It doesn't look like CloudStack because they redid the entire UI, but it has very basic functionality and it works great. So you can start instances, define security groups, create key pairs, things like this. There's not going to be any demo if I cannot get on the network. There you go. So here I have one instance running. As I said, you can define security groups. Within security groups, you can define ingress, egress rules. Okay. So CloudMonkey here is connected to, it's configured to use this exascale cloud. So now I can type, for example, I typed list tab, and it listed all the list type APIs in CloudStack. So all those are APIs that are available that I can use through CloudMonkey. So list volumes, list VPC. What can we do? Yeah, of course, list virtual machines. Okay. It looks a little bit like garbage, but you can filter that. ID name. So you get nice output. So you have a very nice CLI to your cloud, and now you can start messing with things. With libcloud, okay. So if you know Python here, I'm just entering an IPython interactive shell. And basically, I initialized it with some connection objects. So I have a connection, which is an exascale driver. And it has a bunch of methods: create key pair, create node, you name it. So if you do, for example, con list nodes, you see the same node you got, con list images. Okay, you see all the images available and so on. So now you can script and do interesting things. Let's launch. Let's try to launch a Hadoop cluster. So I mentioned this tool from ASF, Where, Apache Where. So it uses JCloud to talk to the cloud. And we're going to give it a configuration file. So it's just launch cluster, and you give a configuration file that just has list of security groups you want, the key pair you want, the software you want installed, the version. So here I'm saying I want the Cloudera Hadoop distribution, things like this. Okay. So it looks like it's starting well. So it's going to start 10 nodes. I'm going to have one name node, Hadoop name node, and then job trackers. So basically, it's using that client, starting the instances, and then it's going to SSH into it, run the bash script. That one is a very basic version of running bash scripts to install Hadoop. And then at the end, it should return and give me a SSH sequence to get on there. So if I look back at my dashboard here, looks like it's starting. So I got all my Hadoop nodes that are starting Ubuntu 12.04. Once they are running all green, then SSH is going to connect and start configuring things. The one that I like a lot is Chef. So CS server list. When I started working with virtualization, all the users said, "Oh, I want a VM. I want a VM. Why? Because I want to be root." I'm like, okay, so here's a virtual machine. You're root. And then after a couple months, they were like, "Oh no, I don't want to be root. I don't want to manage the software. Give it back." So now people are back to kind of using configuration management and not wanting to be root. So that's interesting. So anyway, so Knife. You can do the same thing with Knife. Is it template list? So all those tools give you the same capability, whether it's libcloud, JCloud, Knife. You can list things, list all the templates available. Here, what we're gonna do, just for the heck of it, is this. So that's not black magic. Can you read that? So knife server create. So I want to create an instance, small instance type. I want to use Ubuntu as a template. When that starts, I'm going to SSH as root using this key. When you start the instance, you stick this key pair, which is pre-configured. You use this security group, Elasticsearch. No public IP. That's just telling Knife to not allocate an IP address and try to configure NAT and things like this. And then here, that's the configuration magic where I tell Chef to try to install the Elasticsearch head role. And then I give it a name, FOSDEM. Let's try to start that. So that role, what's in that role is basically a list of recipes that I want Chef to go through to configure the software. And I pre-created this. That's actually the Elasticsearch recipes coming directly from their GitHub repo. So hopefully, if things go well, that starts the instance. That's going to SSH to that instance, install the Chef client, then go through the recipe. And then if everything goes well, I will have a working Elasticsearch with an Nginx proxy running in 5 minutes. Shall we bet? Okay, so during that time, my Hadoop cluster is bootstrapping. All the instances are running. I see my FOSDEM machine has started in a different security group, Elasticsearch. How is JCloud running? Yeah, so JCloud is bootstrapping, setting up lots of rules for the on the firewalls. So we'll let that go, and then I'll get back to it. No. So I was talking about Vagrant, and Vagrant is for developers, but I can see production guys actually starting to use Vagrant because you have configuration management in there that you can share, and then you have plugins to deploy in the cloud. So that's a Vagrant file, and you see again, you specify your box, you specify the host, the keys, and then what's going to happen is that it's going to push that machine. So those are kind of still low-level tools that you can use, but definitely what we have is all the paths out there. Cloud Foundry definitely the big leader in paths. Scalar, Slipstream, which are less known, and then Cloudify, which is gaining quite a bit of traction. And all those work with CloudStack or OpenStack. I don't know if they work with OpenNebula. Probably. So those are some paths. Now, going back to EC2, and we have that EC2 service, we're trying to go, to the left. How about CloudFormation? Can you do CloudFormation with any of those infrastructure as a service solution? So in CloudStack, we now have Stacktician. It's on GitHub. It's a Rails application. So you can actually use the backend if you're low level and you want to just push CloudFormation templates. You can use the backend part of this, which is called StackMate. But otherwise, you have Stackticians, which give you a web front end where you can enter your CloudFormation templates, and then they start. Of course, OpenStack has Heat, which I couldn't find a good picture of Heat, so that's the one I found on Google. As I understand it, OpenStack Heat can also consume CloudFormation templates, and it also does auto-scaling, okay? So we're starting to see those higher level services in any of those solutions. So let's go back and see if we made any headway. Yay! So this is where. So if everything goes well, I'm going to SSH to this guy, which is the Hadoop name node. Okay. And now I should have Hadoop running. hopefully. Yay! Okay. I'm not going to run a MapReduce job, but I want you to trust me that it works. Okay. So you can go and actually put data with the fs commands and then actually run MapReduce and so on. Right now, I don't know, I messed up something with the security group, so it's actually not going to work, but it does work, okay? So I need you to trust me on that. So that's fine. So in like, what was that, 10 minutes, I provisioned a Hadoop cluster in a cloud. I think that's pretty cool. Why am I trying to do this? Because I want to expose a MapReduce API, okay? I would like us to be able to provide an elastic MapReduce service on top of any cloud stack cloud. So that's the basis that you need to start with. You need to be able to start a Hadoop cluster on demand and then, expose Yarn or whatever API there. What's the other one? So Chef is still going. Is Chef still going? Yes. Chef is still going. So to wait for Chef, what we're going to try to do is we're going to try to start another node in libcloud. You guys want to do this? Harm is like, this is boring. So that would be connection, deploy node, you give a name to your instance, FOSDEM1, you specify an image, you specify a size, okay, and then you specify a key name, that's the key pair, exascale. And then you specify a SSH key. Where is the private key for that key pair that you're going to use? And then you specify a deploy script, deploy call MSD. So that's the type of command. I mean, that's much lower level than where or the knife commands. Oh, okay, so knife has finished. So if we go through everything, I mean, it bootstrapped, installed Chef, and then went through the recipes, and then started Nginx. Because if I expose that Elasticsearch cluster, that's not good. So where is that node? So it's FOSDEM. So FOSDEM IP, that's the IP. And you can do curl for Elasticsearch or Chrome as a nice extension, which is it's called sense. So you just specify the IP of that node, 8080, because that's my Nginx port. I set up basic authentication, but I entered the login and password before. So if it's not running. Well, almost perfect demo. Let's go back to this guy. Okay, well, Elasticsearch and Nginx are running, so it doesn't like something. Okay, that was working. How about our node here? Oh, okay, cool. So the deploy has finished here. Now, what's interesting with libcloud is that when you deploy with this, that's just basically a list of scripts. And now I should have the standard out. Okay. When I define this, it's a list of script. One of the script is called script. And then when it finishes, you can get standard out from it. And what I was running was bin date. Okay. That's the hello world of grid computing. So that works. We deploy the node and run some scripts on it. Okay. So now let's finish with my Hadoop. Where destroy cluster config small. Let's just destroy everything. It's on demand. So bing. And what we should see over here is we should see all the instances stop. That's not the part I was expecting to have problems. The network is a little bit... Okay, so the network, probably a problem with the network. Okay, but that's basically it. I think you got the idea that, we're trying to build those higher services. There is a choice of clients and then tools on top of that. And whether you're Python, Ruby, Java guy, you can find your client for whatever solution, CloudStack, OpenStack, OpenNebula. And then we're trying to expose, higher level services that clone Amazon. And we already have CloudFormation. So I think we're going to expect more like Elastic MapReduce, Beanstalk, and you name it. If you want to get involved with Apache CloudStack, look it up. And that's it. Thank you.